Hi everyone, and welcome to our second CEO Perspective webinar, this time on empowering scientists and enabling scale. I'm joined today by Evan Floden, the CEO and co-founder of Seqera, and also the co-creator of Nextflow. Evan, first of all, thank you for joining me today.
Awesome, great to be back, Lizzie. Really looking forward to the series.
Awesome. So my first question, one of the key themes of today's webinar is enabling R&D agility without losing control. So obviously today, R&D organizations are under pressure to scale faster, operate more collaboratively, as well as adopt new technologies and modernize. But in this drive to modernize, many organizations risk underutilizing the most valuable scientific talent due to inefficient tools and processes. So Evan, my first question for you, you've spent years working with teams across pharma. From your perspective, where are organizations still falling short in enabling their teams to succeed?
Yeah, it's a great point and I would like to start there on people and particularly on the scientists themselves. They're still extremely central to R&D outcomes, to project success. But in many cases, the tools and the processes that are being built or being laid on top aren't always built for them. And if you sort of fast forward and think back to, or forward to an agentic or even a co-pilot era, scientists are still going to be very much part of that. And the way that scientists work will definitely change, but we need to be able to support that. And to do that as an organization, this means investing in people. It means in some cases giving them time to try out new things, to be curious about new technologies, and then, so that they're able to come up with solutions, to be able to bring solutions to the particular problems that they have, as well as do a bunch of experiment, which obviously scientists like to do. On the specific kind of tooling side of things, we see there's obviously a lot of fragmentation. This has always existed across R&D, but as more and more work becomes in silico, becomes really reliant on computation, those fragmented systems themselves become almost more of a bottleneck. So we need to think about the infrastructure overhead of that, just in terms of how things are connected together, as well as some of the compliance workarounds that exist there. So when folks have to access data across tools that they have, how can they do this in an efficient way to keep them moving forward with the projects that they have? And then in relation to governance, the challenge itself isn't necessarily about capability there. It's really about the enablement of people to be able to do that. So how can we give the teams autonomy to work, to kind of build, whether this is creation of data sets, construction of cohorts, being able to build and implement, to incorporate new tooling, whilst at the same time being able to do this within the governance structure that a biopharma has.
So it sounds like part of the challenge here comes down to, I guess, visibility and also transparency. So in the past, I know you've described, R&D informatics in many organizations as still operating like a black box. What do you mean by this, and why is it such a challenge for these teams?
We see a couple of different models that exist here. The first one is when we've got research groups or research or processes that are living entirely in a silo, where you may have people running scripts locally, developing their own things, working within a small group. And a lot of those things therefore go undocumented in terms of the software. This may be fine as part of a research project where you're trying to explore and kind of move quickly, but if there's no record of that, it also gets lost from the broader organization who may be able to benefit from the work that's going on. Associated with that then is if analysis is then run and you're taking data or generating data which becomes fragmented, all of that data also gets lost in the same way that the software does. And really when that visibility is lost, so is the reproducibility. So by not creating things in a standardized way, you're really creating friction across all the organization, eliminating a lot of those benefits that we would have from kind of a standardized approach. And then at the other end of the spectrum, we often see this, particularly when bioinformatics or data scientists are operating as a service model within R&D. And in this case, they're often throwing data over the fence, or projects are thrown to them over a fence, and they're kind of having to work, potentially against a timeline to generate a particular analysis. And in that case, really, a lot of the nuances about the science is often lost. This maybe work perfectly fine if you have a standard R&D-seq pipeline that gets run every time, and it's a simple request, which is essentially a service request that's been answered there. But as you go into more complex projects and as you go into more the creative side, which is associated with this analysis, that's where some of the challenges come in. So really, teams need to be able to create that kind of visibility and traceability, which you see, whether that's you're working in a very small group on something pretty niche, or you're generating pipelines or developing pipelines that are used broadly across an organization, not just for the compliance needs, but really to build that scientific momentum that comes across with standardizing on a particular way of doing things, whether that is around how you how code is stored in an organization, how data is accessed. All of these things can be very helpful in terms of being able to apply them across an organization. And by making things observable, by traceable as well, they also opens up that aspect of collaboration. It makes it easier for new folks to come in, for different teams to come in, because there's almost like a shared language and a shared culture of how research informatics is done. Also, so underlying all that kind of software is that sometimes the software does need to be deployed transparently, though. And in software engineering, this is this concept of transparently, meaning that something can happen necessarily without being visible or noticeable to the user. And the underlying complexity of this could be hidden. This could be something as simple as when you're launching a pipeline through a user interface, there's a lot of machinery which is going to be spun up behind the scenes, virtual machines, etc. The user doesn't necessarily need to see that, and it really helps in terms of the seamlessness, but it doesn't mean it has to be a black box. So it's this idea of things happening transparently, but at the same time being traceable, and having that visibility is available there, all the way from very small single scripts that you're running on a day-to-day basis to very large projects where you may be analyzing tens of thousands of genomes.
And it sounds like visibility is occurring at lots of different levels across these organizations as well. And of course, the need for visibility is only growing as, there's a new generation of scientists that are coming in. We've seen how bioinformatics is becoming more important in education today. I know there was a great talk at the NextFlow Summit last year on how NextFlow itself has even become part of, master's curriculum in some universities. So this generation of, scientist developer hybrids is changing how, these R&D teams operate. So from your perspective, what do you think organizations should be doing to support this new generation?
Yeah, it's very much something that we see a lot. Often things have been thought of as this is a CLI or it's a UI, and you kind of don't mix the two worlds. And many of the traditional tools were really never built for these multidisciplinary users. In many cases, like the use cases, are different, but there's starting to be a big sort of mix and merging of those, two sets of individuals or two sets of folks who have those sets of skills across this. I think a big part of this is education system. What we see is that really in all university, college education system and science now these days involves some element of programming, of sort of developer skills. And of course, with things like some of the IDEs, with things like Copilot or Claude or Cursor, it makes it so much easier to get into these environments and to be able to really be productive with them, particularly in a kind of a research setting. So it's that particularly young folks who are coming up, who are growing up with this and coming through the system, they really have a somewhat like different set of skills than was traditionally there. I think in many cases this is a huge positive. It brings the agility to R&D, and it means that you don't necessarily have to rely on other people to do sometimes simple things. In research informatics, a lot of small mundane tasks are maybe very easy for someone who knows what they're doing, but if you don't And if you don't necessarily have the skills of using awk at the command line, for example, it's very tricky to be able to do anything. And that kind of barrier is being broken down and continues to erode. Also, there's kind of that need then for kind of tools to be intuitive and really kind of support that scale without sacrificing a lot of the flexibility. And as we see folks who are kind of coming in who really have almost demands for being able to do things in a way which is programmatic, or they're comfortable in terms of those kind of interfaces, it does enable them to scale as well. Part of that, of course, does involve education and also like the ability for people to kind of take up those hybrid roles within organizations and for organizations to support those kind of people. So overall, the opportunity is really there to kind of build environments that do support everyone, from early career biologists in the lab to people who are exploring into data scientists, to bioinformaticians who are writing algorithms, really being able to find really the right combination of skill sets that are applying from multidisciplinary teams.
Cool. Awesome. Yeah, we've talked a little bit about, enabling agility for this new generation of, scientist developer hybrids. We've seen previously how DevOps, for example, have transformed software engineering. So clearly, by the sounds of it, R&D is next. So what do you think R&D teams can learn from, DevOps and software engineering?
Well, there's a lot of it which is like similar down to the kind of core tooling that we can leverage in science. And this is really one of the the fundamentals of next flow development, was that we would be able to use technologies like containerization, so Docker and GitHub and cloud to apply these things to science. And I think these things still stand the test of time, and in many ways have become more popular and even more relevant today. So teams often are facing these challenges of how you can scale up analyses, the complexity of setting things up, and then being able to collaborate across teams to do so. Those aspects of version control, automation, observability that were typically applied in IT teams can also be applied in terms of R&D infrastructure, and particularly on the aspects of compliance, they become much more important. So it's not necessarily about taking exactly as it is how DevOps teams or software engineering teams work and just applying it to research R&D. It's about thinking about the things which are most relevant, where there is things like version control, understanding reproducibility, maybe being able to link in with access controls around data, really leveraging those pieces in particular, and then applying them in the scientific context. When you do that, when you're able to adopt those practices, you really see a higher quality of R&D that speeds up R&D cycles, reduces a lot of the overheads in terms of compliance and submissions, and builds that really strong collaboration culture, which helps a lot.
So, of course, all of this only works if teams can actually access the tools and the software that they need in order to be able to do the analysis in the first place. So let's next talk about access. So as research environments get more and more complex, why do you think it's so important to make bioinformatics tools more accessible across teams and organizations?
Part of that goes back to that kind of siloing and the splitting up of responsibilities and roles within an R&D organization. That kind of specialization is very important when it comes to some responsibilities, but in many cases it can slow things down. It often means that there is significant reliance on IT support to implement a new tool, to use a new piece of software. Reliance in terms of being able to access computational resources. Now, there's many reasons why you would want to be cautious in terms of unleashing 1,000 GPUs for someone who maybe not so aware of the costs associated with those things. But in many ways, like some of those things can be done in a way where people can get access to the resources in a way which is controlled, budgeted, and often the cost of these things still kind of small and compared to the advancements that you can get in terms of the development as well. Some of the other problems result from tool fragmentation. So we mentioned this before, but being able to bring in the tools that you want into either the platform that you're working in, the environment where you are. Often that should be like just located where the data is as well. And all of those things really kind of restrict the ability to kind of move fast in this regards. In terms of how we can provide solutions to that, doesn't necessarily mean that scientists have to become cloud experts or infrastructure experts just to run analysis. There's obviously an aspect of pipeline execution, which is large-scale compute. And we can create this sort of abstraction, this kind of transparency across running those pipelines to do so. Also can do this in a way we're able to sort of enable this self-service. So with things like Nextflow, you're able to very easily kind of launch very large-scale jobs executions in a way which is relatively kind of simple compared to what you would be doing if you were, say, submitting jobs to a Slurm cluster. Part of this as well, you can always think about how the scientists and include folks like myself, would develop scientific code. I want to be able to mix and match those things together and really making it easy and accessible for me to take something that I've downloaded from GitHub, something that has come from the lab, be able to combine all of the different software together, makes it really easy to move there and reduces some of the friction for being able to move fast. I think for leaders as well, it's often about kind of enabling their teams without compromising the benefits that come from standardization in terms of being able to the collective good of a team or an organization. So being able to get the benefits of being able to move fast while providing that as well.
Thanks, Evan. So during this webinar, we've talked today about lots of different key themes. Obviously, visibility, you just spoke about accessibility, transparency as well, and also the rise of this new generation of, scientist developers. So as we bring this webinar to a close, is there anything you would say to leaders in, pharma and diagnostic organizations who are, looking to support their R&D teams working more efficiently going forward?
The change is real, and I think the pressure that comes with that change is very real. The pressure to deliver faster, to be able to integrate AI into your work, to meet very so often changing and increasing regulatory demands that come across this, and then all of that has been done in this context where we do have to collaborate across different teams to do so. There is this aspect where you can have a lever in terms of like the infrastructure or the latest tool, but I don't think that's the answer to like solving this inside pharma R&D. I think it's really about the people and the culture that you create, the ability where people are free to experiment with new things, but they're also able to bring things in a way where they are aware of some of the standards, they can support their colleagues, and they can work in a way which builds up the culture and the software which is being created inside of an organization, which really leads to being able to build up the science organization. Scientific teams need to move quickly. They need to be responsive in this moment. They need to be adaptable to a lot of the changes that are happening. And as leaders, we can really support them in doing that. I think this is where Seqera can come in a lot to help a lot of organizations to unlock that scientific velocity, create solutions that are scalable, that are secure, really compliant in this way. And overall, I'm just really excited for the changes that are taking place in R&D and really what it's going to unlock for human health and beyond.
Thank you so much for that, Evan. To everyone watching, if you're interested in learning more about how Seqera is supporting, global pharma teams, please do get in touch. And thank you again for joining us.